Question number 19. A giant chunk of diamond weighing 10 grams is heated to 500 degrees Celsius and is then transferred to an insulated container holding 100 grams of water at 10 degrees Celsius. What temperature will the water and diamond be at once the system has equilibrated? So this question, we can immediately see that there's difference in materials. So we know that this is going to use mc delta T. Q equals mc delta T. Now, at equilibrium, when the temperature is the same, we can see that temperature from the diamond, which is heated, will then transfer to the water, which absorbs that heat. So that's why we say that the heat of the diamond is equal to the minus heat of the water, right? Because diamond is releasing the heat, water is absorbing the heat. So therefore their signs will be different. Okay, so now let's work this problem. So we have Q diamond minus Q water. What is released by diamond is absorbed by the water. So we have mc diamond delta T equals minus mc water H2O delta T. Okay, so the mass of the diamond is 10 grams. The specific heat is 0.5 joules per gram Kelvin. And then the delta T is going to be the final temperature minus the initial temperature, which is 500 degrees Celsius. Okay, now on this side of the equation we have 100 grams, and then the heat capacity is 4.184. Same thing, joules per gram Kelvin. And then the final temperature is unknown, but the initial temperature is 10 degrees Celsius. So now if we do the calculations, we can see that it will now become 5.09 T final minus 2545.5 equals minus 418.4 T final plus 4,184. This is just arithmetic and algebra. Okay, so rearrange the equation, we'll get, if we move the 400 to this side, we'll get 423.491 final temperature equals 6729.5. Okay, so temperature final is equal to 15.89 degrees Celsius. Therefore, that means that the diamond and the water will both reach a final temperature of 15.89 degrees Celsius. So you can see that water has such a high heat capacity that the temperature, even though the diamond was 500 degrees Celsius, the temperature is ultimately lowered so many degrees by 585 degrees to 15 degrees Celsius, because there was so much water, and water has such a high specific heat capacity. Therefore, it can absorb a lot of heat before its temperature raises up.